Today, let's talk about matchmaking system. As a matchmaking system, there are a few key tasks you need to handle for us. First, you should match players with opponents of similar skills level based on a certain value. In this tutorial, we will assign a rating based on weapon a player chooses and their recent performance with that weapon in matches. This rating will be used as the basic for matchmaking. Second, once the matchmaking is complete, the system should place a match on the best possible server based on the latency of all players involved. At the same time, we also need to anticipate possible hacking behaviors from the player and design a system architecture in a way that prevent those actions as much as possible. For instance, a player might exploit the system by selecting a rated weapon during the matchmaking to get easier opponents, then switch um, to a high rated weapon once the match begins. This undermines the fairness of the system and negatively impact the experience of other players. To prevent this kind of behavior, we can use AWS Lambda function to handle matchmaking. Inside the Lambda function, we require each player to specify the weapon they intended to use. We then fetch the player's rating for that specific weapon from the database instead of trusting any value provided by the client. To prevent tampering, both weapon and their verified rating are included in the matchmaking data. Once the matches has been assigned to the game server, the server will rate each player's selected weapon from the matchmaking data and spawn the corresponding weapon for them. After that, player will no longer be allowed to switch weapons. Another example is when the player attempts to impersonate another user to enter a match, which could lead to identity or rating manipulation. We'll use either a dedicated server or on the AWS Lambda function behind the appsync web API to ensure that each player's client only receives their own player session ID. Then connecting to the game server for a match, the player will require to provide their session ID for the verification. Another possible issue is that the player might try to impersonate the dedicated server and make requests using the AppSync web APIs that are meant to be used by only the server. This is a concern because our engine compiles both client and dedicated server from the same project, which means the client may unintentionally include APIs and other resources that were originally intended for the server only. We can design an architecture from the start to isolate the dedicated server, ensuring that the logic and resources are not exposed to the client. In this tutorial, we can use AWS credentials provided by the instance role of the AWS gamelift fleet to assign GraphQL web API requests sent from the dedicated server. AppSync will automatically verify the integrity of the request using the signature. These credentials are generated in the real time only within the AWS gamelift managed EC2 instance. So as long as we don't pass them to the client such as through the RPC function, the client will not be able to access them. This effectively isolated the dedicated server from the client. So now let me walk you through the design matchmaking system in details. Let's start with the start matchmaking phase. Within the player character logic, every player is required to confirm their readiness using the ready system before the match can proceed. I covered the ready system in the detail in the last video, so be sure to check out that if you're curious. The game state keeps track of the every player's ready status, and each time one changes, it checks whether the entire team is ready to proceed. When everyone is ready, the game state enters the matching phase. If it is a regular game, we first make sure that there are enough players currently online This is because AWS gamelift matchmaking is built based on the time, so we want to avoid long matchmaking during the whenever possible. After confirming that there are enough players online, we proceed by sending a start matchmaking request to initiate the matchmaking process. For offline regular games, identity verification is handled through the access token. If it is an online regular game, we assign a request on the game server using the AWS credentials generated from the Fleet instance IAM roles. This is an example how we isolate a game server, ensuring that only the authorized infrastructure can perform sensitive operations like matchmaking. Once AWS receives the start matchmaking request, and if it is authenticated via an access token, we parse the token to retrieve the player's identity and related information. Next, we use the player's identity along with the weapon provided in the request to look up their rating for weapon in the database. With the player's weapon and rating information ready, we initiate the matchmaking process through gamelift. Gamelift then returns the ticket ID, which allows us to track of the status of the matchmaking request. When AWS receives the start matchmaking request that is assigned with the IAM credential, we trust the request come from the game server, and we accept the player's information included in the request as valid. Since the request comes from the trusted game server, we use that player info and their selected weapon directly to look up their respective rating from the database. With all the necessary information collected, we then trigger the matchmaking process using gamelift. The gamelift responds with the ticket ID, which the server as the reference for us to query the matchmaking status later. In the case that a private game, we skip the matchmaking steps entirely and send the player straight into the game session to begin the match. After received matchmaking ticket ID, the game state should be regularly pull the matchmaking status. In this video, we'll set an interval to 5 seconds between each checks. In an offline regular game, similar to the start matchmaking request, we use the player's access token to authenticate the request when pulling the matchmaking status. For online regular game, however, the request will be signed using IAM credentials from the gamelift Fleet instance. AWS, if the described matchmaking request is authenticated using the access token, we extract players' information directly from the token. Once we get matchmaking ticket details from the gamelift, we must verify that the ticket actually belongs to the player who made the request. This is important to prevent unauthorized access from other players' matchmaking data. Additionally, we filter out player session details and return only the session ID that the current player should receive. When describing the matchmaking request is signed with a valid AWS credential, we assume it originated from the trusted gamelift game server. In this case, we return complete matchmaking data, including all player session information. If matchmaking fails, gets cancelled, or timeout, the game state will transit back to the waiting status, allowing the players to try again. While matchmaking is still in the searching or placing states, we update each player's player character with the current matchmaking status and estimated time remaining. After the game state detects the matchmaking has been completed, it shares the connection details with assigned game server with all players. Along with that, it also sends each player their own player session ID, which they will need to connect to the game server. After receiving the game server's connection details and their individual player session ID, the player character will try to establish a connection to the game server. When the player clicks the cancel matchmaking in the UI, if the game state hasn't started matchmaking yet, for example, because there are enough online player, it will simply just transit back to the waiting state right away. If matchmaking has already started, we will send a stop matchmaking request to cancel it, just like before. For offline regular games, we authenticated using the access token. For online request game, we sign the request with the free instance role credentials. On the AWS side, if the start matchmaking request uses access token, we first extract player's identity from the token. And then we check whether matchmaking ticket or actually belongs to that player before forwarding the stop request to gamelift. If the stop matchmaking request is signed with the IAM credential, we trust that it is coming from this game server and send the matchmaking request to the gamelift right away. In order to upload our project to the AWS, we will need to compile our project as Linux server executable. We will show you both in Mac and Windows. For Mac, you will need to go to the project folder and type those commands in the terminal, like bash dot slash initiate build linux.sh, and we will just wait till it finished. And in Windows, the step is pretty straightforward and easy. So you just go to the editor and go to platforms, Linux, ARM 64, pick development and the server and package the project, and that's it. After compiling the Linux ARM64 server, we compress the compiled files along with the file required by the server into the zip file. And then upload it to the S3 bucket we created in the first video. We can create AWS CloudFormation stack while we are uploading it using the AWS CloudFormation template we provided with the example project. We can set a position update interval here to convert WebSocket MMO system to the real time. You can change other parameter based on your use cases. After the uploading finished, we get object version from S3 bucket and place it into the game server build object version in the AWS CloudFormation stack. Let's continue after it finishes. After the AWS CloudFormation stack is finished creating, we can set the necessary variables in the game instance based on the CloudFormation stack output. We have added the quick link to the AWS Cognito user pool client so that we could get client secret easier. Let's check the result. We registered two players off screen, test user 1 and test user 2. In this demo, test user 1 will go through matchmaking as a part of the online regular game. Meanwhile, the test user 2 will go through the matchmaking using the offline regular game. Once both users complete ready process, their matchmaking starts separately. Within the raw of 10 seconds, they got matched into the same match. Now let's check how things work with a private game. In the private game, the owner test user 1 assigns both test user 1 and test user 2 to a teams. If you want to learn more about the system, be sure to watch this video. Once both players have marked themselves as ready, they are immediately transported into the match area. That's all.